Hello, in this video we are going to discuss a few debugging questions on arrays. I request you, whenever I display a question, pause the video, try to see the question, attempt it, take pen and paper, solve it, and then go through my explanation. Otherwise, if I explain, you will just simply listen and you will not learn it. Attempting is very important before you understand or go through the solution. Let's see the questions one by one, a few debugging questions on arrays. See this question, we are asked to find out the output of this program. Array A of 4 is given and there are only two elements, that is 25 and 16. Okay. So, we know already and we will see the explanation, and we are supposed to give A of 0 and A of 1, also A of 1 or A of 2, right. So, this is again not the logical operator, it is the bitwise operator, meaning you have to convert this A of 0 to binary, A of 1 to binary, apply this AND operator between those two numbers and then convert back it to the integer. So, first thing here you see A of 0 is given, A of 4 is given, right. A of 4 equal 25, 16, only two values are assigned. So, what about the remaining two values? Those two will be 0. So, my array will look something like this. It will have 25, 16, 0 and 0, indexing 0, 1, 2, 3, right. You solve it and then see the explanation. Okay. Now, A of 0 and A of 1. So, what is A of 0? 25. 25 you convert into binary. Binary in 25 means I have 16, 8, 4, 2, 1. So, I have to put 1 here, 16 plus 8, 24, 0, 0, 1, right. So, this is the binary of A of 0. A of 1 is 16, right. A of 1 is 16. So, what is 16 here? You can put it directly 1, 0, 0, 0, 0. What is the value here? AND means if 1 is 0, answer is 0. So, this is 0, this is 0, 0, 0, 1, meaning it is 1, 4 zeros. Therefore, this value will be 16, right. So, the first printf will give me 16. What about A of 1 or A of 2? A of 1 is 16. 16 means the binary is like this. And what is A of 2? A of 2 is 0. So, the binary is zeros. OR means if anyone is true, the result is true. So, it becomes 1, 4 zeros, right. So, this is again 16. So, answer will be 16, 16 for this question. Let us see the next question. A of 3 equal to, A of 3 is given as 10, 20, 30. It means my array structure contains 3 elements 10, 20 and 30 with indexing 0, 1, 2, right, and a lengthy expression is given here, plus A of plus x plus x plus A of minus x, right. Pause the video, please try to solve it and then go through my explanation. Let us see the explanation here. So, x value is 0, in memory x value is taken as 0, right. You have an expression here, x equal to, let us break that into different steps, plus A of plus x plus x plus A of minus x, right. So, we do from left to right. So, what is this? First I will do square brackets, we know square brackets has more priority. So, plus x means x becomes 1. So, x become 1. So, this is plus A of 1. What is plus A of 1? What is A of 1 value? This one 20. A of 1 value is 20. Plus A of 1 means go to the memory location of A of 1, take that value, add plus 1 to it, store it back in the memory location. Because of this particular variable becomes 21. Okay. A of 1 became 21. So, I will take 21 here plus x. So, x value is 1, plus of x means it becomes 2. So, 2 comes here plus A of minus x, it is pre, here also it is pre, here also it is pre. So, we were incrementing and we were using it. So, here it is minus x. So, x value is 2, minus of x means it becomes 1. So, it is A of 1. What is A of 1 in memory? It is 21. So, 21. So, answer will be 21 plus 21, 42 plus 2, 44. So, 44 will be the solution here. The most important point here is when you saw here plus A of 1, You have to go to the memory location, take the value of A, add +1 to it, store it back in the memory location. Updating the array is very important, like this 21. Okay, right. Let's see the other question. So please see this question. Array is given A with 6 elements there. It has 6 elements, 5 elements, sorry, 6, 12, 18, 24, right. There are 4 elements here, A equal to, there are 4 elements, 6, 12, 18, 24 with indexing 0, 1, 2, 3. So there is an equation given here, try to find out the solution, then you go through the explanation which I give. Right. So let's solve this. X value is given as 0 in memory. So x equal to a of 1 plus, in bracket it is a of 1 equal to 2. So we know in an expression brackets has more priority. So this has more priority. So it is assigning 2 to a of 1. It is assigning 2 to a of 1. So what is there in a of 1? We have 12. That becomes 2. That becomes 2 because of this. And the term here is a of 1. So what is a of 1 value? 2 plus. What is a of 1 value? 2. So this value is 4. So the value of x here is 4. Okay. The value of x here is, are we updating anything else? No. We are just assigning a of 1 equal to 2. Right. We are taking the value as 4. Right. Please see this question. An array is given with 4 numbers here, 0001, 0010, 0100, 1000. I is declared and just printing a of I value. It looks very simple, but there is little logic in this. Please pause the video, solve this, find out the answer, and then go through my explanation. See the solution for this problem. There is one important point here. In a program, inside the program, if you are assigning value to a variable like this, instead of reading it from the scanf statement, if you are assigning value like this, x equal to 1, either you can read it like this, you can assign the value in the program, or you can take it from the user using scanf statement. So in this assignment, if you are assigning values to a variable inside the program, and if you include 0 in front of that, right, then this number becomes an octal number. It becomes an octal number, right. I will discuss cases here. You wrote int x. Using scanf, you are reading the value %d %x. So when you run the program, what will happen? It will display a message, enter the value of x. During compile time, during runtime, during execution, if you write code like this, these 2 lines, and during execution, if you give 4 zeros 1, it will be still, if you give 4 zeros 1, still that value in x will be 1 only. So during execution, during runtime, if you are giving the value with so many zeros, it is still 1 only. Okay, it will not consider that as octal number. Only in the case if you are assigning value in the program. Okay, so during compile time, if the compiler is reading the input value, okay, like this, if you write 01 like this, if you write int x equal to 0001, x equal to 001, x equal to 007, x equal to what all you write, those number are treated as octal number. Octal number. Okay. Now see the question here. We are assigning array values in the program. How are we assigning the values? Array values with the 0001, then 0010, 0100 and 1000. Right. See the last number. It is assigned in the array. It is assigned normally. It is assigned normally. Why? It is written as 1000. So there is no 0 in front. So in the output for loop, it will give 1000 as it is, no change. But the other number you see 0001, it's an octal number, and I am printing %d. Octal number 1 in decimal number is also 1, so no change, so it will give 1. Then 0010, octal number is 10, numerical it is 10. If you convert that to decimal, it becomes 8. Then 0100 meaning 100. Octal number 100 is equal to 64 in decimal. Why I am printing in decimal? Because I have written %d here. %d means decimal. In that number system, decimal, octal, hexadecimal, no. So it is %d means decimal number. So octal 100 is equal to decimal 64. So the answer will be 1,864,000. Okay. Why these three have changed? Because they are in octal representation. 1000 will come as it is. Now you can ask me, sir, what is the format specifier for octal number? It is percentile O. If you want to print the same numbers as it is, if you want the output to be 1, 10, 100 and 1000 as it is, your this will be percentile O. Okay, like this we have different format specifiers for different data types or different types of numbers, right? For this question the answer is 1, 8, 64 and 1000 as it is. Okay, let's see this question. Please read this question, try to guess the answer, pause the video and then go through my explanation. Okay, so we have a 3 by 3 array. Let me draw a 3 by 3 matrix, and by default they follow row major order. So I will fill the values. Anyhow, it's clearly given to us in different in flower brackets. So first row contains 1, 2, 3, second row 4, 5, 6 and third row 7, 8, 9. We are having values neatly in a matrix form. So index is 0, 1, 2, 0, 1, 2. The important point here is, though A by A of 3, 3 we are writing it as a matrix, how is the memory allocation happening? How is the memory allocation happening? Memory allocation is happening for a 2 by 2 matrix or a 3 by 3 matrix in sequential order only. For our naked eyes, for our easy understanding, we are drawing it as box, but inside computer memory, values are stored in a sequence like this. See, 1, 2, 3, 4, 5, 6, 7, 8, 9. This way only it is stored in your RAM. So indexing 0, 1, 2. Again, though indexing changes here, but it is something like this only, which is again calculated internally, right? So again, let's see what is the question here. Percentile D, A of 0, 3, A of 0, 3, right? So if you see, this is 0th row, this row, the entire row is 0th row. That way it is treated. So when you say 0 means first row, okay. Do we have index 3 here? No, we have index only up to 2. What is the index 3 here? We don't have anything here after 2. Generally we think that we are accessing a element outside the range, but actually the answer is 4. A of 0, 3, the answer is 4. Okay, why? Because after 3 compiler goes to here 4. One more example, let me tell you. Suppose the output they are asking is A of 1, 4. If they are asking A of 1, 4, what could be the answer? Let us see. So 1 means this row, second row. In that we have index 0, 1, 2. After that we have 3 and 4. So answer will be 8 in this case. Answer will be 8 in that case. Okay. So from where you are beginning, from there you have to start counting it, because memory allocation is sequence. Memory allocation for a 2 by 2 matrix or a 3 by 3 matrix, it is sequence. That's why compiler is able to give the answer 4 or 8. So for this it is 4. Why? After 3 the next memory block is 4. Okay, that way it is able to give the answers. Next, please see this question, try to guess the answer. We have A of 1 equal to 2. So array A of 1, see A of 1 means there is only one element, so there is only one box. Memory allocation is only 1 and that contains 2. A of 1 means only one element in that array, that is 2. Now printf percentile D 0 of ARR. Okay, so one important point to learn here, we know how to print an element using indexing of array, we print that. So we write A of I like this, or you write A of 1, you give A of 3, so on, you keep writing it. So A of I can also be written as I of A. This is also true. Either you write A of I in square brackets or you write I of square brackets A. Both are valid. Compiler can understand both of them. The meaning of this and this is same. A of I. It is all equal to I of A. Both are same. So if you want, suppose there is an array with 4 elements. Okay, with 10, 20, 30, 40, 0, 1, 2, 3. If you write 2 of A, okay, percentile D in double brackets, if you write like this 2 of A, means it is A of 2, that is 30 is the answer here. Okay, so for this problem, this is just to tell you that A of I can also be written as I of A in square brackets. So A of 0 means there is only one element, so 2 will be the answer here. Yeah, see this question, try to solve it, pause the video, try to solve it and then compare with the explanation which I am giving. right. See the solution. Array A of 5 is given with 1, 2, 3, 25, 7 as the elements. There are 3 variables A, B, C. Let us try to calculate them. A equal to, see, plus A of 1, plus A of 1. What is A of, where is A of 1? This box. Plus A of 1 means take the value of A of 1, add 1 to it, store it back in A of 1. So because of this, this value becomes 3 and A is assigned with 3. A value is 3. Next, B is equal to A of 1 plus. See, this is post increment. This is not standalone statement, it's a post increment. So don't increment it, do this later. First assign A of 1 to B. First assign A of 1 to B. What is A of 1 value? A of 1 contains 3. So this is also 3, but later there is a plus. Because of that, this value becomes 4. Again, C equal to A of A plus. Again, this is array of A plus. So what is A value? This is post increment, you see. This is post increment. So don't increase A value first. Do this later. What is A value? A value is 3. What is array of 3? What is array of 3 value? 25. So C value is 25. Later you increment this plus. Because of this, this becomes 4. A value becomes 4. So what I am printing? Print %d ABC. So A value is 4 in memory, 4 double hyphen, then %d means B value is 3 double hyphen, and C value is 25. So answer is this 4, 3, 25 in this format. Okay. Be careful whenever you see an increment or decrement, if it is pre-increment or pre-decrement, first to go update that and then come and use it. That is an important point here. Next, please see this program, try to guess the output, then we can try to solve, discuss the solution for this problem. Let us see the solution for this. Here they have used hash define A of 5, 1, 2, 3, 4, 5, right, and trying to print A of 1, right. This is an illegal declaration. Okay. In hash define you can give only, no, you cannot declare and assign values there. You can only give some expressions or you can give some functions, but variable declaration or assignment is not possible. Okay. This is not possible because it will replace this term with this term, which is meaningless. Is this meaningless? Is this meaningful? No. If there is an expression x into x, it is okay. Mathematical expression can be used, right. So therefore this will throw error saying that this is an illegal declaration. Yeah, please see this question. Try to solve this. A of 3, an array is declared of size 3, index is 0, 1, 2, I is a variable assigned value 0, and there is some looping statement. You try to guess the answer for this. Let us see the solution for this. A of C, while I less than 3, what is I value? I value is 0. Is 0 less than 3? 0 less than 3, true. Enter. See, A of I equal to plus I. So first do the left hand side, right hand side part. First do the right hand side part. That is the plus I. It is pre-increment. Go and increment that to 1. So this value is 1. Now where I have to substitute this 1? I have to assign this to A of I. What is I value in memory? 1. It means A of 1 is assigned 1. Okay. Now after this, I will go back to the while loop condition. Okay. I value is 1. 1 is less than 3. Yes. 1 is less than 3. It is true. 1 is less than 3 is true. Come inside. Here, after coming here, you will do this plus I first. Because of this, I becomes 2. So this value is 2. Assign this 2 to A of I. A of I. What is I value in memory? Current updated value of I is 2. Therefore, it is equal to A of 2 equal to 2. So 2 comes here. Okay. Next. Again you go back to I while loop. I value is 2. Is 2 less than 3? True. 2 less than 3 is true. Once you come inside, I will do plus I. Because of this, it becomes 3. It becomes 3. So I value becomes, instead of 2, it becomes 3 now. Now A of 3 equal to 3. Generally we don't have any array with location A of 3, but I said that compiler will not throw any error even if you are accessing the other indexes. It will give some garbage value, but it will not give any error. Anyhow, we don't have memory space that will be assigned or it will be executed or not. We are least bothered about it. While loop is over, it will come out the next time. It will come out. No, y plus I means it becomes 4. It became 3. Sorry. Then it will go and check 3 less than 3. It will fail. Come out. After coming out, I am printing I equals 0, I less than 3, I plus plus. So I 0, 0 less than 3 true, print percentile d A of I. What is A of 0 contains? A of 0 contains empty, means garbage. It contains garbage value. Okay, so when you declare int A of 3, and if you don't assign any values to those variable, by default garbage value will be stored in that arrays. Even for normal variables also, if you declare int x and if you try to print x value, okay, it will throw error to you, it will give garbage value to you. Why garbage value? Because it is not assigned any value. By default some junk value is stored in that. That's why when you are printing the array for I0, I less 0 less than 3, it will print these 3 values. What is there in the first box? It is garbage value. So answer will be some garbage or junk value, hyphen hyphen, then 1, then hyphen hyphen, then 2. This will be the, again hyphen hyphen, this will be the output. So it will print garbage 1 and 2 as the answer. Okay, be careful with this assignment, right? It is, see, A of I is equal to plus plus I. This we are doing first. Because of that, this index is also changing. It will take the latest I value, no, whatever is there in the memory, that will be taken. That's why A of 1 is 1, A of 2 is 2. Yeah, please read this question, try to answer this. We will discuss once you go through, once you please pause the video, see, guess the answer for this problem. Okay, A of 3, 4 is given. So it's 3 rows, 4 columns. So it is like 1, 2, 3, 4, 4, 3, 2, 1. I am just assigning them in a matrix form. After that 7, 8, 9, 0. This is the 2D array. We have A of 3, 4. We have 3 rows, 4 columns. Right. What will be the output of the program if the array begins at 65472? Means the beginning address of this block is 65472 and each integer occupies 2 bytes. Okay, so what I am printing here? So this is, again, for shortcut I will take this as 472 only. So this is 472, this is 474. Why? Every integer takes 2 bytes. This is 476. Let's take again short number. So this is 72, 72, 74, 76, 78. This will be 80, this will be 82. Just memory address locations I am writing: 84, 86, 90, 92, 94, 96. Okay, I have correct, no, 72, 74, 76, 78, 80, 82, 84, 86, 88, sorry, it should be 88, 90, 92, 94, 94. These are the addresses of those values. Now they are asking percentile u, again u means unsigned, because for addresses we use unsigned value. A plus 1, A plus 1, okay, in a 2D array, if you write A plus 1, if you write A, it refers to the first row. A refers to the first row starting address, that is 72. Okay, in a 2D array, if you write A, it refers to the address of starting first row. If you write A plus 1, it gives the address of the next row, that is 80, meaning 65480 will be the output for A plus 1. Okay, what is ampersand A plus 1? A plus A is this is A plus 1, this row will be A plus 2, this will be A plus 3. Okay, next, what is ampersand A plus 1? Okay, what is the value of ampersand A plus 1? Right, let us see that. See, A, only A refers to the entire box. Starting address of this entire matrix is given by A, that is 65472. A plus 1 gave us 65480. Ampersand A plus 1, what is ampersand A plus 1 meaning? Ampersand A plus 1, if you give after this memory block the next beginning address, what is the next beginning address? Okay, I will give this example with a small 2D array. So when you give ampersand A plus 1, after this memory allocation of 3 into 4, the next starting address, that is after 94 it is 96. So ampersand A plus 1 will give me 65496. So answer for this problem are 65480 and 65496. And let's understand this small array. I have A of 5 equal to, I will just draw a small box here with some values. Okay, let this address be 100, this be 104, 108, 112, 116, assuming integer takes 4 bytes. Okay, A refers to the name, A refers to this entire block. If you write printf percentile D of A, when you give the name of the array, it gives the starting address of the entire memory block. How much memory was allocated? 20 bytes, because 5 elements into 4, 20 bytes. So, what is the starting address of that 20 byte? That is 100 will be given to you. Okay. When you give A plus 1, it goes to the next box. It goes to the next box in single dimension. In 2D, it goes to the next memory block, that is the second line it goes. Here it will go to 104 only. A plus 1 will give 104. Ampersand A means same meaning. A and ampersand have same meaning. Ampersand A refers to the memory at starting address of this entire block. That is fine. When you say ampersand A plus 1, it gives the starting address of the next memory block. After this memory block is over, what is the starting address of the next memory block? Means from here, means 120 in this case. This will give 120 in this case. Why? Till 116 memory is allocated. Next memory will begin from 120. We don't know what is that, but it will begin from 120. That's why ampersand A plus 1 will give you the next block address, beginning address of the next block, which we do not know how much size it is. We are least bothered about it. So, it is highly encouraged in arrays to use only the name of the array instead of ampersand. We are habituated to use ampersand for every variable to get the address, but for arrays do not use ampersand. That is the reason why when you are reading a string, ampersand is not used, right? Yeah, see this question. Try to find out the value, you pause the video, try to solve this, then we can discuss the solution for this. Let us see the answer for this. See, we know that there are two types of alignment, row measure order and column measure order. So, by default it is row measure order, but sometimes in exam they ask you if it is column measure order, what will be the allotment, right. So, what will be the address of A of 2, 3 if array is a 2D array of 4 rows and 5 columns. Right. So, 4 rows and 5 columns. So, column 2, column 3, column 4 and column 5 like this. Okay. What is column measure order? Elements will fill column wise, not row wise. If I say A of 3, 3, you are filling 1, 2, 3, then you are coming to next row, then you are coming to next row. If row measure order, if it is column measure order, you have to fill like this 1, 2, 3, then next column 6, then 7, 8, 9 like this. So, memory allocation will happen from here and the starting address is given 2000. Okay. So, assume integer occupies 4 bytes. Okay. Assume integer that has to be given, it is missing here. Assume integer occupies 4 bytes. So, if this address is 2000, this again we are not taking any values. So, this will be 2004, this will be 2008, this will be 2012, then here it will be 2016, 2020, 2024, 2028 and so on. So, they are asking the address of A of 2, 3 means 0, 1, 2, 3, 0, 1, 2, 3, 4. Okay. What is A of 2, 3? Second, this third row and this box address they are asking. Address of this box A of 2, 3. So, 28, here it is 32, 36, 40, 44, 48, 52, 56. So, it is 2056 in column measure order. Okay. What would happen if it is row measure order? What is the answer for the same question if it is row measure order? Let us find out that. Okay. So, again same thing, we are having 4 rows and 5 columns, row 1, row 2, row 3, row 4 and column 1, column 2, 3, 4, 5, right. Assume integer takes 4 bytes, we are following about row measure order. So, 0, 1, 2, 3, 0, 1, 2, 3, 4. So, this will be 2000, here it will be 2000, this is 4, this is 8, this is 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52. See, A of 2, 3 is 2052 in row measure order. That is what they are asking, what is the address of A of 2, 3 if the compiler follows column measure order. Let us see one final question in the arrays. Try to solve this. it is interesting. Please take pen and paper, try to solve this. Once you solve it, we will discuss. Please go through the discussion of the solution for this problem. Let us see the solution for this. I request you please solve and then only go through the discussion. So, x is an array, size is not required because the elements are assigned in the program 1 to 8. So, there is an array of 1 to size 8, 1, 2, 3, 4, 5, 6, 7 and also 8. Okay. So, indexing is from 0, 1, 2, 3, 4, 5, 6, 7. Right. Now, see, I value is declared, I is declared without any value, I is equal to 2, 2 is less than 6, true. Come inside, you see the logic there, x of I is equal to x of I. Okay. So, first do left hand side, right hand side. What is I value? I value is 2. What is x of I? X of I value is, that is x of 2 value is 3. X of 2 value is 3 equal to in x of 3. Why? X of I means x of 2. X of 2 means 3. In x of 3, put the value 3. Where is x of 3? This is array x. Where is x of 3? This box. This box. Put value 3 there. First time it is over. Again, next time, second iteration, I value becomes I plus plus, I value become 3. So, x of I is equal to x of I. What is, do the right hand side, what is value of I? 3. That is x of 3. What is x of 3 value? It is 3. X of 3 value it is 3. So, where you have to put this 3? In x of I. What is x of I? X of I means 3. So, in x of 3 put the value 3, it is already 3 there, no need to change, it is already 3 there. Next iteration, I value becomes I plus plus, it becomes 4. So, x of 4, what is I value is 4, x of 4 means 5. Okay, 5 equal to, put that 5 in x of I. What is I value? 4. What is x of 4 value? 5. In x of 5, put this 5. Where is x of 5? Here. Instead of 6, make it this to 5. Again, I becomes plus plus. So, I value becomes 5 this time. 5 is less than 6. Come inside. What is x of I value is 5. What is x of 5? X of 5 is 5. Okay, 5 is equal to. Where you have to put this 5? In x of I. I value is 5. X of 5 is 5. In x of 5, include 5. So, we have this 5 here. That is it. Again, I becomes 6. So, 6 less than 6 false. Come out and just print the array 0 to 8, print the array elements. So, what will be the answer here? The array elements will be 1, 2, 3, 3, 5, 5, 7, 8. This will be the array elements. Right? This is the answer for this program. Right? So, with this we complete the debugging questions. You please practice more from textbook, but these are few of them which I have collected and presented here. Thank you.